Comparing and selecting explainability metrics. To effectively evaluate the explainability of a machine learning model, it is important to use appropriate explainability metrics. These metrics provide quantitative measures of how well a model can be understood and interpreted by humans. In this part of the course, we discuss various explainability metrics, their significance, and how to compare and select the most suitable ones. Let's explore key global interpretability metrics that help us understand and explain AI models. Feature importance. This metric measures the contribution of each feature in the model's decision-making process. It can be computed using techniques like permutation importance or SHAP values. Rule-based metrics. These metrics evaluate the transparency of a model by quantifying the number of rules or logical statements required to approximate the model's behavior. Model complexity. This metric measures the complexity of a model, usually quantified by the number of parameters, layers, or nodes in the model architecture. Understanding these global interpretability metrics helps in gaining insights into the model's operations, ensuring it is transparent and understandable. Let's discover the key local interpretability metrics that help us understand and explain individual predictions. Individual feature contribution. This metric measures the effect of each feature on the prediction of an individual instance. It helps understand the model's decision at a local level. Counterfactual explanations. These metrics generate alternative scenarios by changing the feature values and observing the corresponding changes in the model's prediction. This helps understand the sensitivity of the model to different inputs. Model-agnostic interpretability metrics. LIME local interpretable model-agnostic explanations. LIME generates local explanations by approximating the model's behavior using interpretable surrogate models such as linear models. SHAP, Shapley additive explanations. SHAP provides global and local explanations by attributing the model's prediction to each feature's contribution based on cooperative game theory concepts. When comparing and selecting explainability metrics, consider the following factors. Specific use case. Different metrics may be more suitable for different use cases. Consider the interpretability requirements of your application and select metrics accordingly. Human comprehensibility. The chosen metrics should generate explanations that are understandable to humans, ensuring trust and accountability. Model agnostic against model specific. Decide whether a model agnostic or model specific metric is more appropriate based on the characteristics of your model. Complexity against interpretability trade-off. Some metrics may provide simpler explanations at the cost of losing predictive accuracy. Consider the trade-off between complexity and interpretability. Here are key steps for selecting effective explainability metrics. Review existing literature. Familiarize yourself with previous research or case studies related to the evaluation of explainability metrics in your domain. Test multiple metrics. Evaluate different metrics on your dataset and models. Compare their performance and usefulness in providing meaningful explanations. Stakeholder involvement. Involve domain experts and stakeholders in the selection process to ensure the chosen metrics align with their requirements. Iterative approach. Selecting the most suitable explainability metrics may require an iterative process. Continuously refine and improve the evaluation by incorporating feedback from users. In conclusion, by comparing and selecting the appropriate explainability metrics, you can effectively evaluate the interpretability of your machine learning models. This not only helps in understanding the reasoning behind the model's predictions, but also ensures compliance with ethical and legal standards.